Alright, we have conditional probability and frequency tables today. The probability that an event B will occur given that another event A has already occurred is called conditional probability, and it is written in this format right here. And notice you do the probability of B and then that little line down the middle. It's kind of like saying, I guess, given that A has already happened. One way you can do this here, you randomly select 2 marbles one at a time from a bag containing 3 red marbles and 5 green marbles. If your first marble is red, then 2 of the remaining marbles are red. So the probability of the second marble is red, given that the first marble you already grabbed was red, would be at 2 out of 7. So it's kind of like you're looking at the second part of it. Okay. Now you also have a frequency table. This is getting more into the statistics realm, but a frequency table is a data display that shows how often an item appears in a particular category. And also you have two-way frequency tables. Two-way frequency table or contingency table is data display that shows the frequencies of data in 2 different categories. Okay, so here's an example of one of those right there. So this one here, I guess you got extracurricular activities, male and female, and then involved in activities, and then not involved in activities. And then just for our convenience, they already added up the totals here, which makes our lives a little bit easier when we're writing out our fractions and our percentages. So what is the probability that a randomly chosen student is a female who is not involved in extracurricular activities? So I guess that is assuming that we're picking from everyone, a randomly chosen student there. So as far as the total students there, you have 516. And then we're looking at how many of them are females who's not involved. So you go and find that female, not involved, 120. And then when you punch that out, it's about 23.3%. And I'll erase that. Next one here was a probability using the table above that a randomly selected person is a male who is involved in activities. So random person is selected, so there's 516 total people, and we're doing males that who are involved, so it's 112. Who's involved? Yeah, sorry. This is different in my notes here, so I need a calculator. So that'd be 112 out of 516. And that gets us about 21.7%. So, anyways, what is the probability? Using the table above, that a randomly selected person is a male given that they are involved in activities here. So this is where it gets a little bit different, and this is what you got to look at here. So we're only looking at a specific category. A randomly selected person is a male given that they are involved in activity. So we're actually only looking at this column right here. And there are 251 people that are involved in activities. Those are the only ones we're actually looking at right there. So then we're going to go and see what's the probability that they are a male. So then you look at the 112 right there. And then we'll punch that out. And my notes here say about 44.6% on that right there. So kind of recapping, instead of looking at everyone, we are looking at the ones given that they're involved in activity. So we don't look at the right-hand side, or the right 2 columns, I guess, on this one. And that's where the conditional probability comes in. Given that they're involved in activities, what's the probability that they're male? So we'll try a couple other ones that are, I guess, similar. So I guess you got juniors, seniors, and then you got males and females by grade level on the prom committee. What was the probability that a member of the prom committee is a junior male? So there are 12 people total. They didn't give us any condition, so we're just looking at everyone. And that is a junior male, so that'd be 3 out of 12, that'd be about 25%. Or you could write 1/4. What's the probability that a randomly selected member is a female given that they are a junior? So now we're only looking here at juniors. There's 7 of those total. And then we're looking at just the females. So if we find a junior, what's the chance that it's, I guess, a female junior? So that'd be 4 out of 7. That'd be about 57.1%. Okay. Next was the probability that a randomly selected member is a senior given that they are male. So now we're looking at a whole different column here. So we're only looking at males. And then what is the chance that they are, what is it, a senior? So there's 6 males total, and there are only 3 seniors. So it's about a 50% chance if we're only looking at males. So that's the conditional probability part of it. What is the probability that a randomly selected member is a female senior? So now we're going back. It doesn't give us any conditions, so we're just looking at everyone. So we're looking at all 12. What's the probability that a randomly selected person is a female senior? So there's only 2 of those. So we'll say 2 out of 12, or 1/6, or about 16.6%, or 16.6 repeating percent. By the way to write out, I guess, the conditional probability going out like this, sometimes you might see this here. So we would say, what's the probability if someone was a senior and then given that they were a male? So you might see a couple problems formatted like that. So I didn't write that all the way out on a few of those. All right, example 3. I mean, really, once you kind of start to get it, it's not too bad. There are 150 representatives total. 2 months after his sales seminar, the company vice president made the table of relative frequencies based on sales results. What is the probability that someone who attended the seminar had an increase in sales? So we're going to, I guess, break this down, kind of look at all the different categories here. Probability of increased sales that attended the seminar. So there's that formatting right there. So we'll look at just the people that attended this seminar. So that was about 80%. So we're actually going to use ratios of, I guess, percentages here. So we're going to look at the 80%, and of those 80%, you had 48 of them, so 0.48, got some increased sales. And then when you punch out the math, that's 0.6 or 60%. Or that. So if they went to the seminar, which a lot of them did, 60% of them went up in sales. Let's look at increased sales for those that did not attend the seminar. So we're looking at a different category there. You only had about 20% of those people. So of the 20%, 0.02 saw an increase in sales. So that's about 10% when you divide that. And I'm just getting those numbers. Just type them in the calculator and then move the decimal over twice. Okay, let's look at some of the other categories. No increase in sales and did not attend the seminar. So did not attend the seminar, that was 0.2, or 20% of them. And then 0.18, I guess, didn't see an increase in sales. So that was about 90% of them. And remember, that is given if they did not attend the seminar. And let's see what percentage of people attended the sales seminar but didn't see an increase there. So out of 80% and no sales increase, so that'd be 0.32 out of 0.8, and that's about 40%. Notice for the people that attended the sales seminars, notice 60% of them increased in their sales, and then 40% did not increase. Notice that adds up to 100. And then also notice for the people that did not attend the sales seminar, notice 10% increased their sales and 90% did not increase their sales. Notice that also adds up to 100%. So that goes back to a property saying the probability of something happening and something not happening should add up to 100%. then you got different categories, so you got to look at it differently. All right, use the two-way frequency table to find the Democrat and Democrat and supports the issues, and then I guess we're going to find the probability of a Democrat given that they support the issue. So these are kind of two different things. This first one right here, there are 120 people total, and then we're only going to look at Democrats who support whatever issue that is, and that's about 24 out of that. And that right there is about 20% once you do the math. Now the second portion right here, I guess I'll do this in red. Given that they support the issue, so we're only looking at this column here. There's only 51 people that do that. 24 of them are going to be Democrats right there. So then that'd be about 47% after you punch that out. Okay. So that's kind of the thing there. I guess we have some conditional probability formulas that we're going to use here on this next part right here. And so we don't use the tables as much. But anyways, here for any two events, A and B, the probability of B occurring, given that A has already occurred, can be punched out with this formula here. So you do the probability that A happens, and you put that in the denominator, and then you do the probability of A and B happening right there. So we'll use that here, and then make sure the probability of the first thing is 100%, or it's not 0, I guess I need to say. All right, so let's see what we got here. In a study designed to test the effectiveness of a new drug, half of them received the drug. The other half of the volunteers received a placebo, a tablet containing no medication. The probability of a volunteer receiving the drug and getting well was 45%. So notice here, this is the and word here. So if they received the drug and they got well, that was 45%, and that's out of everyone total there. So what we need to do, yeah, I guess I already kind of listed it out here, probability of taking the drug, and then we need to figure out the probability of taking the drug and getting well. So we just said that was 45%. As far as taking the drug, it said half of them took the drug and half of them didn't. So we'll say 50% for the half that did take the drug. So now what we're going to do is look out of that 50% of people that took the drug. 45 of the total people got better. So then when you compare those two right there, that means if they took the drug 90% of the time, they got better. That's what that means in everyday terms there. So we're looking at just that 50% that took the drug. 45% of the total got well in that situation there. So. All right, so this next one here. A survey showed that 45% of pet owners own a dog, 27% own a cat, and 5% own a dog, a cat, and at least one other type of pet. So we'll use that information here for the conditional probability. What is a conditional probability that a pet owner owns a cat and some other type of pet given that they own a dog? All right, so we're going to look at just the people that own a dog, and that'll be our 45% in the denominator. And then we're going to look at those people that own a dog, a cat, and at least one other type of pet. So that's that 5%. Oh, whoops. And we'll write that as 5% right there. You can convert them both to decimals if you would like there. But you have that right there. And then when you simplify that down, it'll be about 11% there. Okay, so that's comparing the people that not only own a dog, but own all the other stuff right there, given that they own a dog in the first place. All right, so next one was a conditional probability that a pet owner owns a dog and some other type of pet, given that they own a cat. So now we're going to just look at strictly the people that own cats. That's 27%. We're going to compare that to the 5% that own a dog, a cat, and at least another type of pet. So that'd be 5% over 27%. And that comes out to about 18.5% in that case there, once you round. There, so You're only looking at a specific percentage of them there. Okay, let's look at example 3. A survey shows that 10% of students walk to school, 80% of students drive to school, and 5% of students both walk to school and also drive to school. Okay, so this right here says find the probability that they drive and walk given that they drive. So we're going to look at just the students that drive. There's about 80% of them. And then we're going to compare that to the 5% of students that walk and drive. Guess maybe if it's a nice day, they walk. If it's not nice, they drive. Not sure what the context is, but anyways, 5 of the 5% over the 80% that drive, period. It simplifies down to 1 over 16, or it's about 6.25%. Okay, next one right here. Find the probability that they drive and walk given that they just walk. So if you look at just the 10% that walk to school, and then we're going to compare that to the 5% that walk and sometimes even drive. So that would be about 50% right there. 50% of the kids that drive and walk, given that they walk in the first place. And that's what that means. Okay. Next few right here, we can use a tree diagram to help ourselves out with this next one here. So a college reported that 70% of its freshmen had attended public schools. 60% of the freshmen had attended public schools and graduated within 5 years. 80% of the other freshmen graduated within 5 years. What percentage of the freshmen graduated within 5 years? So here what it's kind of saying is, like, for example, of the people that went to the public schools, 60% of them graduate, 40% did not graduate within that 5-year time period. So I guess this is kind of looking at colleges right there. So it's not saying 60% total, it's saying 60% of the public school and then 40% of the public school right there, not total percentages. So I think the whole idea of this is we're going to find all the total percentages and then figure out, the specific ones they're asking for right there. All right, so what we'll do is, and this is kind of like, I think there's a formula from yesterday that said this, the probability formula for this, public and they graduated. You're going to take the probability of the public and then the probability that they graduated given that they went to the public school, and then you'll take those and you'll multiply them. So we got to look at all these different numbers here. So first of all, let's figure out the probability that they went to a public school. And that was about 70%. So we'll put 0.7. And then the probability that they graduated was 0.6. But we're only looking at that graduated of the public school. So in a way, they gave us the conditional probability part already. And we're trying to find the real probability. So when you look at that, that's about 42% right there. Once you multiply those, about 0.42 if you use your decimals, but then 42%. Of your total students that you're looking at went to public and graduated. Okay, so the percentage of the students that went to another school and then also graduated, well, the other schools, that's about 30%. So we'll go 0.3, and then graduated in the 5-year period, that's 0.8, so we'll go times 0.8. And that'd be 0.24, about 24%. Right there. So then after that here, we're going to figure out the probability that they graduated, period. So we're going to look at the people that graduated, both of these sections right here, but we have to look at these probabilities because we're looking at the total probability there. So then we will take those two and we will add those up. So we need to figure out the probability that they went to public and graduated and the probability that they went to another and graduated. Essentially, you just add up your two percentages that you got here. So we're going to go 42%. 42% of your total students went to a public and graduated, and then 24% of your students went to another school and graduated. And then once you add that up there, you get 66% graduated, period, in that time period. Which also from here you can go and look at, well, what percentage of them didn't graduate. So you could say, if you wanted, 34% did not graduate in time. Or graduate, I guess, in the 5 years period. But that wasn't really part of the question there. That's just a little extra tidbit. Once you go and find all of these percentages, when you multiply and then multiply, all of the percentages that you put over here, if you put them on the left-hand side, all of them should add up to 100%. So, a little extra tidbit there. So, all right, let's use, I guess, kind of the same idea here. We'll use another tree. A soccer team wins 65% of its games on muddy fields and 30% of their games on dry fields. The probability of the field being muddy for the next game is 70%. Was a probability that the team will win their next game. So we're going to look at the two cases here. You got a dry field, and then you got a muddy field. All right, the percent of chance that the game is going to be muddy is 70%. So I'll put 0.7 for muddy, and then for dry, we can just subtract that from 1 right there, and we can get 0.3, or 30% chance that it'll be dry. Okay, so we'll look here then at the muddy game statistic here. They win 65% of those. So we'll say they win, and it's 0.65 of those games. So then that means they lose. Oops. 0.35. Okay, now if we go to the dry games here, we'll see what works for that. So win, what does it say? They win 30% on their dry fields there. So yeah, there we go. We'll go 0.3. So then that means they lose 0.7% there. And then after that, we'll take all of that information there and we'll start figuring out the probability that they win, period. So we need to figure out the probability that it's dry and they win. And to do that, we take those two and multiply them. So it's 30% chance that it's dry, and then there's a 30% chance that they'll win that one if it's dry. So that would be, 0.09. And then the probability that it is muddy and that they win. So 70% of the times it's muddy, and then they win 65% of those right there. That, for whatever reason, is not punched out on notes here, so let me do that. 0.7 times 0.65. That's about 0.455. So then the combined winning percentages there, you just take your 0.09, your 0.455. And that gets you 0.4. I'm sorry, 0.545 right there. Or you could say 54.5%. So that is the probability that they will win, period. And that's not considering the muddy or the dry. That's just period. That's the percentage that they have to win right there. Anyways, that is it for our lesson.